Today we'll be talking about physical quantities, units, and measurements. And some of the learning outcomes will be to understand that physical quantities have numerical magnitude and the units, to recall base quantities and use prefixes, to show an understanding of orders of magnitude, to understand scalars and vector quantities, to determine resultant vector by graphical methods, to measure length with measuring instruments, and to measure short intervals with time using stopwatches. So, the first aspect of physical quantities. Let's talk about the quantitative versus the qualitative. One thing is that most observation in physics are quantitative, and descriptive observation or qualitative are usually imprecise. What do we mean by qualitative observations? How do we measure artistic beauty? How can you tell that something is beautiful? What measurements are you going to use for that? Like looking at the picture now, how will you measure the level of beauty of this thing compared to another thing? That's what we call qualitative observation. That is based on quality. But when talking about quantitative observation, looking at that laboratory now, what can be used with the instruments on an aeroplane? That's like a mini lab, or let me just go straight forward. That's like a plane. Uh, so the question is that what can be measured with instrument on the aeroplane? Are we trying to measure the pressure, the temperature? What can be measured? So if something can be measured, it means that that thing has quantity. We can hold it, we can grasp it. So should I say that it's not abstract? That is something that is concrete. So most of the quantities in physics that we measure are quantitative. They are concrete. They are things that we can hold. But when talking about qualitative observations, you can't be precise because it varies from one thing to the other. Let's define what a physical quantity is. A physical quantity is the one that can be measured and consists of a magnitude and the units. A physical quantity is one that can be measured and consists of what? Of a magnitude and the units. What do you mean by magnitude and units? Let's give an example that is the speed of something is 70 kilometers per hour. Then the 70 there is the magnitude and the kilometer per hour is the units. So it is very important as a science student to know that both the magnitude and the unit are very important. You can't say 70 meters. Then we are talking about something else. I can't ask you that what's your age now, and you tell me that your age is 10. Is it 10 years? Is it 10 minutes? Is it 10 seconds? Is it 10 decades? Do you get it now? The units of what you are talking about is very important. Or I just asked you what's your age now. You are now telling me 10 meter. You can see that you are not longer talking about the age. Maybe you are talking about your height or something else. It means that the magnitude, that's a size, like this 74.5, that's the magnitude, while the units are the kilometer per hour and the other one is a meter. The unit of the first one makes us understand that that 70 kilometer per hour is the speed. This second one, 4.5 meter, is distance. So vehicles not exceeding 1,500 kilogram in unladen weights. SI units are common today. Even if you want to measure using a ruler, you want to measure, you have to give what? The units of what you are talking about. So you get that now. So let's talk about physical quantities. Physical quantities are classified into two types. We have the base quantities and the derived quantities. Sometimes some people call the base quantity the fundamental quantities. Looking at the word fundamental, the foundational. So fundamental quantities are those quantities in which other quantities are built on. There are seven in numbers, and apart from those seven, other quantities are built on them. So it means that they are the base quantity, the foundational quantity that determines other quantities. So the derived quantities are just integral multiples of fundamental quantities. So the base quantities and derived quantities are the two types of what physical quantities that we have. Let's look at that building. The derived quantity is like the house that was built up from a collection of bricks. That's the basic quantities. So the bricks are the what they are the base quantities, while the house is what is a derived quantity. So the bricks, the basic quantity, while the house, the derived quantity. So the base quantity is the brick, the basic building of a house. So it means that when talking about derived quantities, you can see that the derived quantity has a house on its own. It's gotten from what? From the combination of what? Of the base quantities. Let's talk about SI units. SI units means what? International System of Units. And talking about the base quantity, the other time I told you that there are seven in numbers, and that's what? The length, the mass, time, electric current, temperature, amount of substance, luminous intensity. So if they ask you that what are the fundamental quantities, or they ask that what are the base quantities, so these seven are the fundamental quantities or the base quantities that we have. Any other quantities that you hear in physics are different from these ones, they are derived quantities. Let me say that pressure now. Pressure is not part of these seven, therefore, pressure is what is a derived quantity. It's not a base quantity or a fundamental quantity. And apart from knowing these seven that have base quantities, it is also very important to know the unit of each of those quantities, because length is always measured in meter, the short form is small m. Mass is always measured in kilogram, that's kg. So if I say 3 kg now, you know I'm talking about mass. So time is measured in seconds, that's small s. If I tell you that something is 40 seconds, you know it's time. So electric current is ampere, that's capital A. So temperature is measured in Kelvin, that's SI unit, capital K. Amount of substance, that's mole, MOL. The luminous intensity, that's candela, and that's CD. So make sure you know the base quantities, the unit of the base quantities, and the symbol of those units. So these seven on the right are base quantities. They are the fundamental quantities, and the units are called the fundamental units. So if they ask you in an exam that you should list fundamental quantities, just list all these seven. All these seven are the what? Are the fundamental quantities. And all these seven units are the derived quantities. So let's continue. SI units now. This is a platinum iridium cylinder, and is actually the standard for the kilogram. So we always compare uh, the mass of objects with respect to this platinum iridium cylinder. What's splash? Okay, area. What's the meaning of area? This is something you have been hearing since your primary school days. Volume, density, just with speed. These are some things that we're talking about in physics: accelerations, force. There are many of them: pressure, work, power. All of those ones are what they are derived quantities, because they are not part of the what for the fundamental quantities that we mentioned. So examples of derived quantities, I can say they are area. And when talking about area, the formula of area is just what? Length times breadth, or I say length times width. So and in terms of units, the unit of area is going to be meter times meter, because the length is a meter. Even width is a form of a length, also a meter. So the unit is meter square. Let's talk about volume. Volume is also a fundamental quantity. The formula for volume is length times width times height. The length is a form of a meter. The width is a form of a length too, is a meter. The height of a building is also a form of a length, is a meter. So talking about length times width times height. So I can say that what? Meter times meter times meter, and that's what? Meter cube. Sorry for that. That should be meter cube. Okay. Meter cube, not meter square. Okay. So let's divide the equation. Density, formula for density is what? Mass divided by what? By volume. Mass divided by volume. Mass divided by volume. And mass is a kilogram, and we've said that volume is a meter cube. We can say the unit of density was kilogram per meter cube. Let's work out some derived quantities. Distance over time, that's speed, and velocity over time is what we call acceleration. So we must know the formula of some things while trying to work out the derived quantities. And the unit of speed is going to be, because distance is a meter and time is seconds, so that's meter over seconds, meter per seconds. while the unit of acceleration will be what? Meter per seconds square. On the unit for forces mass times acceleration, mass is in kilogram. Since the acceleration is in meter per second square, so I can say the unit of force is kilogram meter per second square. So pressure is force over area. Unit of pressure is going to be force is what? Kilogram meter per second square, then over another area. That should be kilogram meter is minus 1 second square. So you can work that out, then compare uh, the solutions. So you can work those ones out. So let's talk about some derived quantities. Area, that's a formula. I'm trying to give you some formulas because it's those formulas that you use to what to break down some things so that you can get the fundamental quantities that makes up the derived quantity. That's the blocks that make up the building. So that's for that. You should fill in those things and submit it at the end of the class. Those gaps. Learn to fill those gaps and submit at the end of the class. So let's talk about prefixes. What do you mean by prefixes? Prefixes simply find the writing of very large or very small quantities, especially in science when we have very large quantities or very small quantities and we want to write it in an abridged format or in a very simplified format. That's when we use what prefixes. So, and these are some of the common prefixes that we have. Nano, we use small n, and nano means 10 is minus 9. Micro is like that thing that looks like mu, that's 10 is minus 6. Milli is small n, 10 is minus 3. Centi, we use small c, that's 10 is power minus 2. Deci is small d, that's 10 is power minus 1. Kilo is k, that's 10 is power 3. Mega is capital N, that's 10 is power 6. Giga is g, that's 10 is power 9. Tera is capital T, that's 10 is power 12. So it goes like that. So, but those are the common ones. We still have beta, even the lower ones that we have Zupto, we have Zupto, and all those things. But those ones that I've mentioned, they are the common ones. Make sure you know some of these sub multiples and multiples. If, for example, if I say 2 kilometer now, you should know that that kilo is 2 times 10 is power 3 meters. If I say 3 milliseconds now, then you should know I'm talking about 3 times 10 is power minus 3 seconds. If I say 4 microfarad, what I'm trying to say is that 4 times 10 to minus 6 farad. So that is the abbreviation for each of those prefixes. So let's talk about alternative writing method using standard form. I believe that from your elementary mathematics, you know what we call standard form. Standard form is of the form n times 10 to the power n, where n is between 1 and 10. So it's between, or let me say, is greater or equals to 1 or less than equals to or less than 10. So between 1 and, or let me say between 0 and 10. So we can have 1, 2, 3, 4, 5, 6, 7, 8, 9. So at least the n must be an integer, a single number, not double number. So when some is standard form, it means that no matter where the point is, we try to bring points on to the front of the first integer. So talking about the universe, this galaxy is about 2.5 times 10 passes light years from the Earth. That's the Alpha Centauri. And talking about the subatomic level, the energy level, the nucleus in chemistry, the diameter of an atom is about 1 times 10 minus 10 meter. You can see the way we write notations in physics, trying to write them in standard form. We will not write 2500000 light years now. It's too long. Or if you are talking about diameter of an atom, now is 0.0000001 meter. It's somehow. So it's better to write them in standard form like this: 1 times 10 minus 10 meter and 2.5 times 10 is power 6. So that's the light years. So some of the key concepts that we've talked about so far is that a physical quantity is a quantity that can be measured and consists of a numerical magnitude and a unit. A physical quantities can be classified into base quantities and derived quantities. There are 7 base quantities: length, mass, time, current, temperature, amount of substance, and luminous intensity. The SI units for length, mass, time are meter, kilogram, and seconds respectively. Prefixes are used to denote very big or very small numbers. I hope we get uh, what we've talked about so far. Maybe next class we'll continue to talk about other things. So let me just give you some questions that I want you to write down and solve for me. The first one is talking about you should name the base quantities and identify their units. What are the convenient ways of writing very large and very small quantities? You can, the second one is to rewrite the following quantities using suitable prefixes. The third one is to rewrite the following measurement in the unit suggested. And the fourth one is that how many bytes of memory space are there in 80 gigabyte hard disks? B in gigabyte stand for byte. I think I've said that now. So in next class we're talking about the scalars and vectors so that the length of this video will not be too much. Thank you very much.